Hey guys, hope that all is well. Hope you guys are doing well and had a happy new year and all that, and happy holidays. So what we're going to start working with today, we're going to start with this new unit. It's going to be on bisectors, and more specifically, angle bisectors. It's nothing difficult. I don't know if you've ever actually heard of the term or not, but what a bisector does, it's any line, it's any segment, it's any ray, it's anything that cuts an object in half. That's what a bisector does. It cuts a figure in half. An angle bisector is more specific because what an angle bisector is, it's a line, a ray, or a segment that cuts an angle in half. And that's why it's called an angle bisector, because it cuts an angle in half, right? And so just to give you an idea of what an angle bisector is, let's say that we had an angle that looked like this, right? What a bisector would do is literally a bisector would take that angle and it would cut it in half, right? And for us to know that that's cutting it in half, let's say that the entire angle was 100, right? If the angle's getting cut in half, if the actual angle was 100, now all of a sudden these two would become the same, right? This would be 50 and this would be 50. And they'd both be the same because again, if we're cutting an angle in half, they're both gonna be equal, right? And that's what an angle bisector does. An angle bisector actually makes both angles exactly the same, and it makes it the same because again, this is in the middle, right? This here, that angle bisector, that's in the middle, right? It cuts the angle in half. And so what happens when we actually know that it's cutting it in half? If this is a bisector, it's in the middle, automatically we know that this angle and this angle are the same, right? So if this here and that here, they're the same, right? Which would mean if this is 50 degrees, going back to our original example, this is going to be 50 degrees, right? Because again, that's what a bisector does. A bisector literally cuts an angle in half. So if the angle is cut in half, we know that those two are going to be the same. But there's more that comes from that. Because if this is a bisector, it means that this is perfectly in the middle, right? Since that's perfectly in the middle, if we were to draw, let's say, a line to this point here, and then another line to this point, right? And it's not just the fact that we're just drawing lines here. We know that it's going to the same point in the middle. But more importantly, if I make this a right angle, and I make this a right angle, what that's telling us is with the right angle, this line is going straight to the middle. If that's a right angle, this line is going straight to the middle. If they're both going straight to the middle, right? And we know that these angles are the same because those angles tell us that this is in the middle. If these two are going straight to the middle, then it also means that this and this are the same, right? Because if the angles are congruent, and we have right angles, which tell us they're going straight, if the angles are congruent, and then these are right angles, automatically these two segments are always going to be congruent. Because it goes with that idea, which is if the angles are congruent, and we have right angles, which tells us the segments are straight, then automatically those segments are congruent. Which means if this is 8 feet, automatically this one here is also going to be 8 feet. And that's what a bisector does. It literally, an angle bisector cuts the angle in half and basically makes both sides congruent as long as we have right angles. Those right angles are extremely important. And so they don't always need to give us this because even if I were to get rid of this, I put that there just to show you guys. But if I were to get rid of this here, we also automatically know that if these two are congruent, then automatically those are congruent, right? And we also know that the opposite is also true, right? We know that, let's say that I were to show you that the segments are congruent, right? And I'll show you what I mean with this. Let's say, again, we have the same idea, right? We have an angle right there, right? Let's say that we have this ray in the middle, right? No, it doesn't look like it. Don't worry about it like that. Let's say that we have this point here, right? We have this point there as well, right? And again, let's say that that's a right angle, this is a right angle. And the importance of those right angles is exactly that. The fact that they're right angles tells you that that's going straight, that's going straight. And now let's say that this is the same as that, right? Let's say that this is 6 inches. Let's say that that's 6 inches, right? The opposite now is true too. Whereas if we have two segments going to a line, right? We know that those two segments are equal. We know that they have right angles, which means they're both going straight. So if you have two segments that are going straight to the middle, if they're both the same, automatically we know that these two angles are also going to be the same. Automatically. If these two segments are congruent and the angles are right angles, automatically these two angles are congruent. Which means if this is, let's say, 32 degrees, automatically this one will be 32 degrees. Because it always goes opposite ways. If the segments are congruent, then the angles are congruent. If the angles are congruent, then the segments are also congruent. It's the good thing about this. And since these angles are the same, we know that that's a bisector. Since these two segments were congruent, we know that that's a bisector because they were both straight to the middle. That's what an angle bisector looks like. That's what it's always true. We know with an angle bisector, whenever we again have right angles, it's important. We know that those segments are congruent, and we know that the angles are always congruent, right? But now, how do we use this idea? How do we actually use this? And this is the easy part. It's actually, we can use this to be able to solve for segments. We can also use it to solve for angles, right? By using equations. So let's say that I gave you this illustration, right? And again, let's say that I have that, I have that. That's a right angle. That's a right angle. And again, I need to tell you that this is congruent to that. It's extremely important because now what we know, again, before we even start, since these two angles are congruent and those are right angles, automatically we know that this and this are congruent, right? So let's say I want to give you that this is 5m. Here, let me do a different color just so you guys can actually see it better. Let's say that this here is 5m minus 22, right? And let's make this 18. Let's say I actually wanted to solve for m, right? If I actually wanted to solve for m, again, we know this idea. We know that these two are congruent. So if those two are congruent, automatically those two segments are congruent because they're right angles, right? So if they're congruent, it means they're the same, they're equal. So if they're equal, we know that 5m minus 22 equals 18. Because it's that same idea that we did before. If the two angles are equal, then these two segments are equal, right? So we know that 5m minus 22 equals 18, right? Now once you have that, it's just solving, right? Because we want to get m by itself. Let's get rid of the 22 first. That's not the variable. Opposite of subtraction is addition. Add 22, add 22. Those two cancel. So we're left with 5m equals 18 plus 22 is 40, right? Now again, m by itself, opposite of multiplication, we would divide by 5. Divide that by 5. 5's, they eliminate. So we have m equals, we know that 40 divided by 5 is 8. And again, that's just how you use this idea. You use it to be able to set up equations, because if the angles are congruent, then the segments are congruent. And we know we're right, because let's just say we wanted to check it. We know that m is 8. If we were to substitute 8 over here, we know 5 times 8 is 40. 40 minus 22 is 18, which is what we said from the beginning. 18, 18, they're both the same, right? Let's try one just so you guys actually see how it also looks for angles. It's the same idea still, guys. It's just getting comfortable with seeing it, and you guys actually do well with solving equations, which has always been a good strength for you guys. Again, let me draw this one as well. So let's do this. Let's say that we have that, right? And again, we have this segment there, and we have this segment. Again, the right angle is extremely, extremely important. Let's make that congruent to that. So automatically, if those two are congruent and those are right angles, we know that this and this are both going to be equal. Those two angles are going to be equal, right? Okay. So now let me show you this. Let's just say that this angle here, let's just make that 2k plus 35 degrees, right? And then let's make this one here, let's make this one 6k plus 25 degrees, right? So this angle here is 6k plus 25. This angle there is 2k plus 35. And again, we want to solve for k, right? So if we wanted to solve for k, same idea. If those two segments are congruent, these two angles are congruent, right? So we know that 6k plus, I'm sorry, 6k minus, that should be a minus, I'm sorry about that We know that 6k minus 25 degrees is equal to 2k plus 35 degrees, right? And again, it's that same idea, guys, that if the segments are congruent, then these two angles are congruent. They're both equal to each other. 6a minus 25 equals 2k plus 35. And once you have variables on both sides, you guys have done well with this. You've figured out the trick, which is if you can always do it, get rid of the smallest variable first to make your life a lot easier, right? Out of this, we know that the smallest variable is the 2k, right? So since the 2k is positive, to eliminate it, to cancel it out, we do the opposite, which is a minus, a negative, right? So minus 2k minus 2k. The 2k's cancel out. So we know 6k minus 2k is 4k, right? And then bring everything else down. Minus 25 degrees equals 35 degrees, right? Because now from here, you all can do this, right? Opposite of subtraction is addition. Add 25, add 25, right? The 25's cancel, so we're left with 4k equals 35 plus 25 gives us 60 degrees. And now if we have 60, the way that we get k by itself, to isolate it, opposite of multiplication is division. Divide by 4, divide by 4. The 4's cross out, they eliminate, and we're left with k equals 15 degrees. And we got 15 because, again, 60 divided by 4 gives us 15, right? That's how you would actually check it out. And now if we really wanted to find this out, because again, it's just applying all this to be able to figure it out, the math itself is easy. If I wanted to know the measure of each angle, pick one, right? You can substitute into this one, you can substitute into that one, it doesn't matter, because in the end we know they're both equal. So I always say go for the easiest one. Easiest one out of these would be the 2k plus 15, 2k plus 35. We know that k is 15, so we have 2 times 15, right, plus 35. 2 times 15 is 30. 30 plus 35 gives us 65, right? So this angle here, we know that that angle is 65 degrees. Automatically, this other angle would be 65 degrees, which we know again. 6 times 15 is 90. 90 minus 25 gives us 65. But again, we don't have to do both because if one is the same, one is 65, the other one has to be. But again, when it comes to this, this is just figuring out what the measures are. But the only way you can figure out the measures of angles is if you actually solve for k, right? And always remember, if the segments are congruent, the angles are congruent, right? So if the angles are congruent, you always just set them equal to each other, okay? Don't ever forget that, guys. If you have any questions at all, always feel free to ask, all right? Take care.